Hi, this is Mrs. Secord. If you can find this page in your notebook, we're going to do 3 pages today, a little bit more difficult problems. Okay, today we want to find the area of this blue section right here. Now, a way that we might do this is if we could find the area of this sector with the 90-degree angle, and if we would subtract then maybe this triangle, we would find this shaded region. Okay, so let's take the area of the sector and let's take the area of the triangle and subtract it. Okay, so this section up here minus the triangle will give us the blue. Okay, you notice that the area of the sector is 1/4 of the circle, and remember area is pi r squared and the radius here is 6, so 6 squared is 36 pi. 36 pi, and then if we take 1/4 of that, we end up with 9 pi. And then our area of our triangle, well, look, that's a radius. So this is a radius, so this also must be 6. So the area of our triangle is 1/2 6 times 6, and that gives me half of 36, which is 18. So the answer, the area, even though it looks strange, is 9 pi minus 18. Now if we wanted an estimated value, we could multiply 9 times pi and subtract 18. And I think you get about 10.26 if you do it, okay? After that area is. Okay, let's try the next one. Here we have another triangle that we want to cut out from the sector. So we're going to, let's write down what we're going to do here. We're going to take the sector and we're going to subtract the area of the triangle again. And the area of the sector, let's see, this is 120 out of 360, and that's a third, right? 1/3. So it's 1/3. Now our radius is 12 and our area is pi r squared. R is 12, so 12 squared is 144 pi. And 1/3 of 144 is 48 pi. 144 divided by 3. And our triangle area, oh, here we have a little bit of dilemma. I see it's an isosceles triangle. How could we find the height of this triangle? If we drew in an altitude, we did some problems like this. If that's 90, and if this is 120, and I bisect this, here we've got a 60-degree angle. Oh, it's the old 30, 60, 90. And the hypotenuse is 12. So that makes the short leg 6, and it makes the long leg be 6 radical 3. Okay, so now we're going to find the area of the triangle. That formula is 1/2 base times height. The base here will be 12 radical 3, 6 radical 3 and 6 radical 3. And the height of the triangle is 6. And half of 12 is 6. 6 times 6, that's 36 radical 3. Okay, so then our answer, the area is 48 pi minus 36 radical 3. Okay, next one. Okay. Ooh, this is kind of strange. And I noticed your shading didn't come off in your notebook. Can you shade everything but this little part of a circle at the top? Now this idea, I think what we want to do is find the area of the triangle, okay, in here. And then find the area of this part of the circle, because you know what? If that's 90, isn't this 270 right here? And 270, you know 270 out of 360 is 3/4, right? So if we could take 3/4 of the circle and add the area of the triangle, then we'd have everything shaded. So let's write that down. We want the area of the circle. No, yeah, 3/4 of that, right? And I guess I want to say that's a sector. Let me just get this right. The area of this sector. And the area of the triangle. And I want to add it together. Okay, the area of the sector, that's 3/4. Now the radius is 8, so it would be 64 pi, right? The area of the circle, 64 pi. And then 4 goes into 64, I think 16, right? So 3 times 16 is 48 pi. Now the area of the triangle. If this is 8, this is also 8. It's a radius, base times height. So it's 1/2 8 times 8. And half of 64 is 32. So if we add these two together, the 3/4 of the circle and the triangle, we have our area. Okay, and the next one. Okay. If we find the area of this sector and then subtract our triangle, we'll get this part, right? What I'm saying is if we find the area of this whole sector, the green and the yellow, and then subtract this triangle, we would get that area. All right, so area of the sector minus triangle area will give us our answer. All right, this is not maybe that pleasant, but here's what we have. We have 1/6 of the circle, right? 60 over 360. 1/6. And if the radius is 8, then it's 64 pi. Here's where it gets tricky. It doesn't divide nicely. I think it reduces 64 over 6, comes down to 32 over 3, 32 pi over 3. And the area of the triangle, half, and the base, well, 8, but I don't know what the height is. Well, if I drop this in, oh boy, here we got an equilateral triangle. If this is 90, this is the 60-degree angle. Here's the 30. All right, this is 4. And the height of this triangle is 4 radical 3. So our base of the triangle, 8. Our height 4 radical 3. 8 times 4 is 32, half of 32, 16 radical 3. So the area is 32 pi over 3 minus 16 radical 3. Okay, the next page. Here we have a circle inscribed in a square. Okay, so if I take the area of the square and I subtract the area of the circle, I will get the answer. The area of the square, 10 times 10, right? The area of the circle, well, the radius here, if this is 10 clear across, then half of it must be 5. So the area of the circle is 25 pi, right? Radius squared, pi, radius squared. So the answer is 100 minus 25 pi. Again, these look strange, but you could multiply 100 and then, subtract 25 pi, 25 times 3.14, and subtract it from 100. And I think you end up with something like 21.5. Okay, now this next one. Oh, we have a half a circle, and we have a rectangle. If I drew that in, wouldn't that radius be 6? Okay, so if I take my rectangle area and I subtract the area of the semicircle, I will find my answer. Okay, so the rectangle's dimensions are 12 by 6. 12 times 6, which is 72. And the area of my semicircle is pi r squared. The radius is 6, so it'd be 36 pi, right? But I want a semicircle, I want half of it. That would be 18 pi. So the area is 72 minus 18 pi. And thank you.